Good morning, and I'm super happy to welcome you all for the webinar on Artificial Intelligence Transforming Healthcare. I'm your moderator for today's webinar, Dr. Bhuma Pullat Marikanan. Today, the theme of this webinar is Future of Data in Healthcare. The main objective of this webinar is to get students aware of what's new and what's possible in the digital era where AI is driving change around the world. So, as over the last few years, artificial intelligence simplifies the lives of patients, doctors, hospitals, and hospital administrators by performing tasks that are typically done by humans, but not in less time and also fraction of cost. AI has countless applications in healthcare, whether it being used to discover links between genetic codes to power surgical robots or even to maximize hospital efficiency. In 2015, misdiagnosis illness and medical error accounted for 10% of all US deaths. In light of that, the promise of improving the diagnostic process is one of the AI's most exciting healthcare applications. Incomplete medical histories and large case loads can lead to deadly human errors. Immune to those variables, AI can predict and diagnose disease at a faster rate than most medical professionals. In one study, for example, an AI model using algorithms and deep learning diagnosed breast cancer at a higher rate than 11 pathologists. So joining us today, an expert and a lead principal data scientist, Mr. Tarun, is a business and IT professional with over 25 years of industry experience in programming, data science, DevOps, business intelligence, data warehousing, machine learning, and deep learning. He earned his doctorate in international finance from the University of Maryland through coursework, his MBA and MS degree from Loyola University, Chicago, with high honors. His BBA and BS degree in accounting science. Tarun is the founder and CTO of Abandon, a big data analytics and digital transforming company specializing in digitizing IT stacks. He has been involved in data mining, engineering, and science for the last 15 years. Tarun is also running a podcast called IT Time with Tarun, where he interviews IT entrepreneurs through his channel. You can also find it on Spotify. You can also find some of his video on the abandoned YouTube channel. At CATS, Tarun is a principal data scientist working on EdTech initiatives to spread the word data science throughout the region. So without further delay, on behalf of School of Computing and APCA Research Center, I'd like to welcome Mr. Tarun and his team on board. It's so happy to welcome you here.
Hi, good morning. Good morning. Okay, let's first start. What we're going to do today is we'll start with a brief introduction who we are, and then we'll follow by Mr. Tarun's session. Okay, let me first share my slide here. Can you guys see my slide? Can you see the slide?
Not actually, Messina.
No, not yet. All right, I'm sharing it. Just a minute, stop sharing.
I think yes, now we can able to view your screen.
Okay, you could? Okay, just let me try again.
Okay.
Can you see now? Just give it some time. It says it's sharing my screen now.
Yes, now we can able to see your screen.
Okay, great. Yeah, just put it in full screen, right? Okay, so let me share with you who we are first, and then we'll follow by the session. Okay. Okay, so CATS in short, it's actually the Center of Data Science, Applied Data Science, is an AI tech company that helps enterprises maximize business potential by becoming a data-driven organization through a data-literate workforce. Our mission is to future-proof the world by improving data literacy of the workforce. So, becoming a data-driven business doesn't always come easy. That's because data and technology alone won't make an organization more successful. It requires a shift in mindset and efforts from leadership and employees together. So at CATS, we help orchestrate this change, work with management to get their buy-in, and future-proof talents with data literate skills. So how do we do that? All right. With the help of our AI technology solution, that we help scale and accelerate digital workforce transformation using our Celtic Enterprise Solution platform. These are more for enterprise organizations to join this platform, and also to our Rubik Data Professional Network platform. We'll be discussing a little bit more on Rubik later on in the session, where we will help you, if you're interested, to get on board Rubik and to see where you can go from here. So basically, these two platforms is a vibrant community platform for data professionals, where you can start your journey to become a data professional and network with organization, learning institute, and all others in this platform. Okay, so from here, what do we do? Once you're on this platform, we are able to identify your skill gaps, and then we will introduce you and propose you our training and upskill, how we upskill workforce in the area of data literacy. As you can see, the next box here, we are showing our learning pathways. All right. So we have several learning pathways. We start with very basic entry-level programs, such as Enterprise Data Practitioner, that can be around 7 days for you to complete this program, followed by a very beginner level program that's an Associate Enterprise Data Analyst, where you learn programming, Python, SQL over here. And then we follow on with more technical programs such as our Enterprise Data Analyst, Enterprise Data Scientist, Enterprise Data Analyst, which some of these programs can go up to 22 days the most. All right. So these are learning pathways, and all these learning pathways are certified and recognized by the Malaysian Board of Technology, and also internationally recognized by Informs. Informs is a body recognized in US for analytic programs and talents. All right. And the following thing on Data Star, we have another program called the Professional Placement Program, where this is suited for all fresh graduates, and also graduates are working for 3 years now. And if you're looking at changing your career or thinking of going into data professional, this would be a good route, where we are providing a scholarship, and it's called a Data Star program. And I'll talk a little bit more on Data Star in my next slide with you, all right? Okay. Our presence, we have been around in Malaysia since 2014. We started off in 2014 to be the voice of data science. We supported the development of Malaysian digital economy by creating the ecosystem where we bring together demand and supply of data professionals, all right? And our main operation is headquartered in Kuala Lumpur, but our headquarter is in Singapore. We are operationalized in Kuala Lumpur and headquartered in Singapore. And here is where we are driving our regional ambition, and we have our presence now in Thailand, Philippines, Vietnam, Indonesia as well. All right. So this is something that we are moving forward in 2020 onwards. All right. Just back. Okay. And we have around 60 staff in the company currently. And over the years, we have managed to over 100 organizations we are supported in our digital agenda, and by upskilling talents in the company, and also looking at how they can helping them in becoming a digital, data-driven organization. All right, and as I mentioned, we have trained over 6,000 alumni over the years from professional tracks that I showed you earlier, and also our Data Star program here. As I mentioned earlier, it's a program to fast-track development of data professionals. So we have successfully trained 249 data star programs, all fresh graduates coming into this program over the years, and we have placed them in different industries. These are some of the industries you see on the slide that we work closely with, and also many more. And currently, we are training around 225 data stars would be graduating this year, already graduated last year and this year. And we are actively placing them into all the industries, all right? And for the next 2 to 3 years, we are looking at training more 500 odd data star students. So this is a scholarship program. If you're interested, you can apply with CATS, and there's an assessment process onto this, and see if you're lucky, you would actually win a data star scholarship. All right. So the next slide is this. What I'm showing you here is just some testimonials from all the data stars, some of the data star students who have completed the program and what they have learned and gained knowledge through the program. Just a sharing with, if you are looking at it, and what some of our students have gone through the program or what they are saying about the program. Right? Okay. Becoming a data star, if you are in our data star program, you have opportunity to also take part in hackathons and datathons that we co-organize with universities and organizations. And here we provide the mentorship. Our data scientists provide the mentorship for you to actually try your luck and go into this competition and see how you gain your experience from here. All right. I think that's about it. So if you're interested to know more about us, we are located, our head office, our operation office is at Bangsa South. And our email is info@thecats.com. Website is www.cats.ai. And you can also reach us at our social media, and we're constantly posting a lot of programs in the social media. Connect to us and you'll be updated accordingly. All right, that's about it. Thank you. Now Tarun will take over to go ahead with the session. Let's stop sharing here.
Okay, thank you. So I'm going to start sharing. And hopefully it just works. And let me blow it up a bit. Okay, can everyone hear me? And can everyone see my slides? Yes, okay, great. Okay, welcome everyone. Thank you so much for attending, first of all, this webinar. And thank you, of course, to CADS and APU for hosting this. So my name is Tarun Sukhani, and as mentioned in the introduction, I am a principal data scientist at CADS. I'm also the founder and CTO of Abundant. Abundant focuses more on the applications of data science, the actual implementation. So, one of the, of course, goals, we should say, of healthcare is to live longer and healthier lives, right? We want our quality of life to be high, even in our so-called senior years, right? AI and machine learning, data science can actually aid in that goal. So what I'm going to do is I'm going to go through Industry 4.0 and digital healthcare. And as some of you may already be aware, there are 9 pillars in Industry 4.0. I've kind of grouped 4 of the pillars into what I call hyperconnectivity. And I've grouped the other 5 into what I call hyperconvergence or superintelligence. And this is a more kind of arbitrary designation here. But I think it will make sense as we go through this presentation why I refer to some of these as hyperconnectivity and some of them as more hyperconvergence or superintelligence. So without further ado, let's get into what is Industry 4.0, and then we can get into the pillars themselves and how each pillar applies within healthcare. So Industry 4.0 applies to the fourth industrial revolution. And even though it concerns areas that are not normally known by themselves as industries, such as smart cities. So essentially Industry 4.0 encompasses, not only industries and technologies, but business processes as well. And, so this can run the gamut of, smart factories and smart cities, all the way to simple control systems that are essentially hyper-connected. Here are some of the Industry 4.0 technologies and also process trends. First and foremost is the Internet of Things, and accompanying that is the Industrial Internet of Things. The only difference really between the two is scale. Then we have cyber physical systems. Okay. By the way, I mean, these are just fancy words. Cyber physical just means that there's a feedback loop. So that way that the system is aware of its actions and can actually improve upon itself. Smart manufacturing, smart factories, cloud computing, cognitive computing, and of course, artificial intelligence. If we look at the progression of digital transformation, regardless of healthcare or any other industry, we've come actually a long way in the last 40 or so years. It kind of started off with the personal PC revolution, right? With Apple Computer and IBM and all the other stuff getting into the fray of personal computing, right? And personal computing kind of kicked it off, right? From personal computing, obviously, now that everyone had a computer in the home, right? People started to consume news and media on their machines rather than newspapers and physical media. People then, of course, started to get into e-commerce. From there, we jumped into Web 2.0, and we suddenly realized that most of the data being created after we made that switch to Web 2.0, most of the data being created, well over 90%, of course, including up to today, is essentially Web 2.0 data. This is big data. It comes in a variety of forms, and then that was kind of like the precursor to the social media explosion and social business that we see today, right? So if we're talking about, social e-commerce, if we're talking about AR, VR, MR, the goal of all of these systems is really essentially hyperconnectivity, but at the same time, right, giving a full integrated experience for the consumer. So, it's trying to mimic like what we're doing in the physical world, right? Where you do have a social component and interaction, right? Let's take a look at one definition that I found quite interesting of digital transformation, and I think this actually showcases really in a very short period of time what digital transformation actually entails, and then we can apply that to healthcare. So hopefully the sound just works. Did the sound work, by the way? Let me just confirm that it works. Okay, great. Thank you.
McKinsey recently published a good article titled Speed and Scale, Unlocking Digital Value in Customer Journeys. My intent is to enhance the content and to provide a one-page blueprint for effective and scalable digital transformation. Let's use an information-centric legacy company such as a travel agency, financial, or insurance company as our example. Such a company has many internal elements such as people, processes, data, applications, organization, and culture, and external elements such as suppliers, vendors, and governments that interact with one another to provide value to the customer. Until the last few years, the external pace of change has been slow, and therefore the elements that make up the company did not have to change that fast. Now the environment is much different. Today, the customer may be interacting with the company through multiple channels, such as online and through agents. They're looking for simple and seamless ways to interact with the company. For example, when a customer uses a music download service, he expects to search, buy, download, and listen to the song of his choice within a few seconds. If this interaction becomes painful, he will quickly move on to other companies that offer a better experience. Customer journeys are the mechanisms through which companies interact with their customers. For effective business transformation, we need to focus on such journeys while, at the same time, take into account the whole ecosystem of interacting elements that make the journeys possible when designing the digital future. But it would be very difficult to take all journeys into account for digital transformation. The best option is to first select a subset of such journeys as a starting point. Which of those journeys to pick depends on the importance of that journey to the customer experience and may be based on criteria such as high volume or high impact. More importantly, they have to align with the digital vision of the company. Once a small set of journeys are picked, they have to be modeled so that they can be reimagined and digitized. We should not attempt to simply digitize an existing journey, but rather look at how the journey can be improved. For example, you may want to reduce the number of steps. Each step in the journey may focus on certain attributes. Branding may be important in one step, while speed may be important in another. Each step in the journey is essentially enabled by modular business services that can be reused in multiple places. In this example of a customer purchasing insurance, one step requires the customer to digitally sign the acceptance. Such a business service can be reused in multiple places across multiple journeys. This means that foundational architecture has to be built in a modular fashion so it can be reused. As we design and deploy more and more of these journeys, the library of such reusable business services will continue to grow. As the environment changes, the business services will be updated to meet the new requirements of the ecosystem. With time, e-signatures may be replaced by retinal scans, and updating the single business service can ensure automatic propagation to all the places that used to use e-signatures. Such modularity, flexibility, and reconfigurability allow the organization to continue to adapt to the ever-changing business environment. These business services are in turn supported by applications and technology infrastructure that have to be integrated. However, by isolating technology in terms of business services they provide, it is possible to switch out certain modules of technology gradually instead of completely revamping the whole infrastructure. While all this is reality, we need architecture models to represent the reality so it's easier for us to understand and manipulate that reality. The architecture represents different types of entities such as people, processes, technology, applications, data, etc., and the relationships between these entities. Changes to the reality can be communicated through changes in the architecture. The architecture in turn has to be governed, changes budgeted for, and planned. The overall plan for digital transformation includes other aspects such as change management, talent management, and a mechanism for continuous adaptation. Change management permeates the entire organization to enable mind shift in the culture. Current expertise and skills of people have to be upgraded to meet the digital needs of the organization. One of the most effective ways to help employees increase their digital knowledge is to team them up in work cells, which include a cross section of people from different areas to collaborate. As new techniques and approaches are available, they are fed into the teams so they can continue to mature. The transformation journey never ends, continuing to evolve and adapt to the changing business and customer needs. As the transformation rolls out, the metrics and key indicators that used to be relevant in the legacy context are not necessarily relevant anymore. New metrics have to be developed and monitored to provide a real-time dashboard for leaders to make decisions and fine-tune the organization. All the influences of the ecosystem on the business is considered and the cycle starts all over again. This blueprint is not comprehensive and is intended to just give an idea of the things that have to be considered in a digital transformation effort. Each of these steps can further be expanded into multiple levels of detail for an efficient execution, and more elements can be added to this blueprint depending on your needs.
Okay. So yeah, so I thought that was a good kind of summary of what's happening in digital transformation nowadays, and I wanted to emphasize a couple of things, which was the architecture and the talent management, right? The architecture governs the way your organization will communicate and essentially work, and of course, your talent management determines what you will do in the future, right? So let's get an introduction into digital health, within this topic, by taking a look at this video.
If you're online, the internet can play a big part of your daily life. With a PC, tablet, or smartphone, you really can have the whole world in your hand. You can go shopping, do your banking, buy tickets for travel, get information, or simply keep in touch with family and friends. There's a lot you can do online when it comes to taking care of your health too. From apps to help you boost your well-being, to potentially connecting with your GP surgery. The option of booking appointments with your GP or ordering repeat prescriptions will soon be available to more people. And in the future, you'll be able to access a summary of your medical record online, along with other services and information, perhaps through just one website or app. Your medical record will be more joined up, bringing together information held by your GP practice, any hospitals you visit, and eventually any social and community care services that you access. The record will also be available to appropriate professionals involved in your care, so they can securely share and see your information whenever this is useful. Joining things up in this way could help improve the support you receive and your healthcare experience. Having access to your medical record could make you more informed about your healthcare and about your conditions, and help you manage them better. So, what do you think? Do you have any thoughts or ideas on how this could work for you? We'd love to hear from you. So why not get in touch today and find out how you can...
Okay, so basically, the center of a lot of our digital universe or digital universes is the mobile phone, and obviously people have focused on mobile applications as an entry point into digital transformation, right? But of course, a mobile phone by itself is insufficient, right? So when we're talking about digital health, right, we're talking about the convergence and the connectivity of multiple devices and people, right? So I think we saw the smart wearables, right, smartwatches, et cetera, as being one of the key ingredients to this. So other ingredients, include virtual and augmented reality, right? So for example, if you need to do a procedure, or if you're doing, for example, training, if you're an anesthetist, or if you're a nurse, or any other type of medical staff, essentially your training can be completely transformed through virtual and augmented reality. If you're, for example, drawing blood for the first time, right? You can actually put an augmented reality mesh, on the patient's arm, actually identifying what is the normal area you'd look to draw blood from. So there's a number of these applications that are coming online that are essentially helping medical professionals on the training realm, right? We'll see that later as well. Care delivery in the home will move beyond basic telemedicine. Clinical outcomes will be tied to relevant financial ROIs. Chronic and complex diseases will be treated with digital solutions. Senior care will be reimagined. Whole person care will be provided via one-stop shop platform or platforms, and prescribed digital therapeutics will become widespread. So let's take a look at how we can combine Industry 4.0 and healthcare, and what that could look like.
Industry 4.0 will facilitate various functions when applied in the medical field, mainly reduction of cost and time with superior accuracy and quality of work, better tools and material management, use of blockchain technology for the information management of medical history, vaccines, and medicines, which can be used for analysis at any given time. Complex surgeries can be completed with correct control processes. Customization of artificial organs will be more streamlined and successful. Help in more centralized database for the government to have more data-driven policies with better result-oriented solutions. The technologies introduced into the healthcare sector due to Industry 4.0 has provided a sense of security and consummation among the end users and the patients on whom they are used. Use of robotics in a surgery room where a doctor controls a robot from a computer sounds too sci-fi, but it is a reality now. Risky environments for the surgeons can also be avoided now. Big data provides critical insights for prompt and healthier dealing of an illness through meticulous data analysis of current and historical medical situations of an individual. One of the biggest achievements in the field of modern-day healthcare facilitated by Industry 4.0 is the use of holography. 3D imaging has enabled doctors to check on patients without physical presence of either of them and identification of the level of diseases. This is feasibly the chief contribution of Industry 4.0 in the field of healthcare. 3D printing and scanning with the help of 3D CAD data, use of AI to ease diagnosis-related difficulties and drug development. Sensor to check on parameters like blood pressure, temperature and heart rate are some other technologies that have and are being developed to bring fast-paced change in the field of medicine and healthcare. This technology revolution has birthed an inimitable milieu for the healthcare industry to cultivate a landscape where the sky is the limit to what can be achieved. Both the approach of the doctors and patients, along with the healthcare industry, will change, hopefully for the good, and new era for healthcare will transform the industry for good. To know more about Industry 4.0 and smart operations in various sectors, stay tuned to our channel FERS EDU and
Okay, so I mean, that video obviously showcases, how technology and big data can work together, right? So let's go through the major trends in healthcare today, and hopefully into the future. So first and foremost, we have value-based care. So the emphasis now is on quality of care, right? Not on the volume of procedures, right? And of course, it should always be that way, right? So this means that providers will have to start absorbing non-quality risks associated with healthcare, right? In other words, the focus should always be on quality of outcome, right? Diagnostic precision. With advancements in genomics and imaging, I think a lot of you may have heard of CRISPR-Cas9, for example, and it was mentioned in the video about holography. Less waste and error is introduced into diagnostics. Computer vision systems have already been implemented with higher accuracy rates than expert doctors. That was already mentioned by Dr. Booma. So a lot of these things are already present. And we have to look at healthcare as essentially a holistic delivery, right, of quality therapeutics and curative agents, right? And so it kind of all starts off with diagnosis, right? That's the starting off point. And then we can obviously get into therapeutics and curatives. And then finally, we can get into overall preventative maintenance and long-term care, right? So if we look at healthcare from the perspective of your life, 0 to 100, so to speak, right? Or maybe beyond 100, as I mentioned. What we're really looking at is at each stage in your life, right? How are you gathering information? How is the information about your health being gathered, right? How is it being applied, right? And what is the outcome, right? How can we measure quality outcomes? So clinical analytics is another part of this. This is where the big data comes in, and I think the video talked about that as well. Because big data basically means we're collecting all of this information using smart wearables and other devices that are on your person, right? And it's constantly, streaming this IoT data, which is essentially big data, which essentially gives the medical staff, your clinician, information about your overall health profile, right? As you age. Molecular medicine. This is where CRISPR-Cas9 and other technologies have come into play, and they've, in some cases, completely transformed healthcare from being therapeutic to be completely curative. Smart care. As the number of elderly continues to increase around the world, people don't want to, stay in hospitals and clinics, or even, elderly care homes. Ideally they would want to be at home, right, with their families. So, the importance of telemedicine and smart care cannot be understated here, right? And moving on into this topic a little bit further, right? There's also the question of accessibility, right? So it's not like everyone in the world lives in major cities, right? So and ideally we wouldn't want that anyway, you know. Ideally, what we would want is for people to live in any size city and have access to the same quality of healthcare, and that is possible, through the proper use of IR4 technology, right? 5G, AR, VR, MR, and so on and so forth, being a critical part of that. So we've actually reached the end of the first stage of our presentation, and I wanted to actually go into a quick quiz. So if all of you can actually scan this, with your mobile phones, or if you want the link, we can provide the link in the chat, and you can actually connect to this kind of quick quiz. And I'm not sure if Azhar is going to be conducting this, but Azhar, if you want to kind of take over, I can stop sharing my screen and you can start sharing yours.
Yeah, all right.
Okay,
sure.
Great. So I'll stop sharing and you can take over.
I've started sharing the tab to the games. Yes, yes. So we've seen like some papers are coming in. All right. So this is like an overview of the overview that Tarun has already delivered, and we are going to take a moment like thinking through and like having a foreshadow of what Tarun is going to deliver next. We are going to cover like two main parts, which is the hyperconnectivity and also what is it the other one, Tarun?
Super intelligence.
Yes, super intelligence. So
Yeah.
we are just going to go the overview of it. All right, so we will start maybe like less than 30 seconds. Everyone can have a moment joining in, maybe like troubleshooting your phones or your QR. So how many people have joined? Let's see. So 5 people. Anyone else? Do you need more time to connect?
I'm not sure if everyone's using the link or if they're trying to get the QR code.
Maybe another 30 seconds.
Sure.
All right, so let's start. I'm going to start the game now. Do your best. This is quite straightforward. Seven people already answered. So some of you miss, is it? Yeah, so superintelligence is actually covered by big data and simulations. Cybersecurity, in a sense, it's not really about intelligence, it's about connectivity. So we are controlling about how others from different points are connecting between each other. Yeah. So next questions. Maybe you can already like guessing if we are covering the first one is superintelligence. The next one would be what are hyperconnectivities? All right. So let's see. Awesome news. Like literally awesome news. So the right answer would be only Internet of Things. This is only among the three choices, but there's actually like four hyperconnectivity. Yeah. So augmented reality is more to intelligence. It doesn't actually connect. And also additive manufacturing is more like a process. Next question. How do you understand the term digital health in brief? One word would suffice, I think. Just give you a moment of your thoughts. How do you understand the term digital health? Okay, we're seeing some response now. I'm so curious. The other half is still thinking. And so, what's your answer? So, digital health is about reading? Might be. Healthcare advancements supplemented by AI technologies. Yeah, that's possible. IoT plus healthcare, yes, precision medicine. Exactly. Not really exactly, but yeah, sure. Database accuracy. There's also online health record tracking, technology which is combined with health. Awesome. So what's the next question? All right. Awesome. Okay, and Nicole. So the right answer will be finding cure as much as convenient as providing therapy. I think Tarun already mentioned this. It's more like with AI, we have more hope to cure rather than just providing like reducing our symptoms. We are literally targeting the disease itself. Okay, online drug selling to consumer, I think it is possible. There's like rules and regulation constraint, and yeah, and also like security itself. A community of immortals are developing happily. There's one person answering that. I mean, it's probably possible in the future. Maybe. Maybe we could hope so. So, next question. All right. What are your answers? It's actually true. Computer vision has already been implemented and it has higher accuracy rates than expert doctors have done. Yeah, so that is all. Tarun will take back.
Okay, thank you. Thank you so much, Azhar. So yeah, I'll start sharing again. And let's go back. Okay, so we're on autonomous robots now. So let's talk about each of these pillars, starting off with autonomous robots. So first and foremost, when we talk about robots, right, usually what comes to mind is science fiction, like Terminator and stuff like that. But in the real world, in our world, we're not there yet. So in our world, when we normally talk about robots, we talk about industrial robots, right? And you've seen these in automotive factories and elsewhere. Usually there are a bunch of arms. They can be even, of course, more advanced than that. What we see with Boston Dynamics, for example, is a lot more advanced. But essentially, industrial automation is what has led the development of advanced robotics in the last 4 decades. And again, the goal here has always been, right, to provide greater safety, a greater efficiency, and of course to remove, the mundane kind of, anodyne existence of a lot of these tasks, right, that ideally should be done by machines rather than humans. So when we talk about industrial automation, we're talking about 2 major things, okay? We're talking about autonomy and automation, okay? Automation is what we call lower levels of autonomy, right? And they will like pick up this thing and they'll put it over there, and that's pretty much all they can do, right? They can't really learn anything. When we get into more advanced levels of autonomy, what we're really talking about is applying, artificial intelligence, machine learning to robotics. Okay, and we call these, smart robots, right? And there are many examples of smart robots being used today, in diagnostic systems, for example, or in warehousing, right? So, the advantage, of course, of autonomy is that decisions don't have to be made now by humans. Decisions can be made by these machines, such that, you don't have to micromanage, the factory floor, for example, or micromanage every single decision. So, here are, the typical pictures that you would see, right, from factories, the so-called robot arm, but also, other types of robotics that are more mobile, right? So we can, of course, see that with Boston Dynamics. We can see that with warehousing robots. where mobility is critical, right? Let's take a look at robotic
Number
surgery.
8, innovation in robotic surgery.
An extension of the physician's hands, robotic surgery provides pinpoint accuracy. Advances in the field range from the development of more accurate planning tools and software to increased automation of tasks during surgery. Precision surgical arms designed for proper instrument positioning and implantation during spinal surgery increase surgeon precision. Automating the bronchoscopy process avoids incisions with the insertion of flexible tubes through the body's natural openings. Using a controller-like interface, this advancement increases accuracy and safety while decreasing invasiveness and cost. Robotization is also reaching endovascular procedures like percutaneous coronary intervention, PCI, and peripheral vascular intervention, PVI, which traditionally require the surgeon to wear lead. Using robotics now lowers risk for patients and the surgeon while improving outcomes. Robotic surgery provides precision, flexibility, and control. Paired with shortened recovery time and limited pain, patients benefit from the continued advancements in the field.
Okay, so this kind of goes back to what. By the way, that's the Da Vinci robot, that robotic robot, and it can also be, tele remotely or remotely operated. So that's pretty cool. I mean, you could be doing surgery, and this has already been done. You can actually watch the video where surgery was done remotely. So I think you can see the benefit right away. So this is not just about precision medicine. Right. And I think what I wanted to emphasize from the very beginning, digital healthcare is, if I were to sum it up, is about improving the quality of health outcomes. Okay, so that's what fundamentally it's about. And if you look at robotic surgery, what is it really about? It's about getting the patient in and out, right, of the clinical setting as quickly as possible with as less pain as possible, right? So if we always focus on the quality of the outcome, then we can see where digital healthcare really is going. Whether it's actually curing genetic diseases or reducing outpatient time, or making sure that inpatient care is optimized with the most amount of autonomy as possible, right? We don't want micromanagement, and anyway, human beings are not going to be able to do that, okay, effectively. So machines will be able to do that. Monitor every single, second or less, right? So the benefits are less traumatic and minimal scarring, improved surgeon's comfort, targeted approach, greater focus, precision accuracy, reduced duration of hospital stay, quicker recovery. So these are all the things that I pretty much kind of touched on. So let's take a look at medical transportation robots.
Yes, they will. You record them. Excuse me. Calling elevator. Calling elevator. Waiting for clear elevator. Approaching elevator, please stand aside. Approaching elevator, please stand aside. Waiting. Entering elevator. Turning around.
Okay. So anyway, I mean, robots like Tug or whatever, can go into patients' rooms, right? They can be used for a number of purposes, for resupply. A lot of these robots are being used for sanitation and hygiene, for UV, for example, for sterilizing COVID rooms. Can go in and UV the entire place. So that's where these robots really come in handy, right? Let's move on to the next pillar with IR4, which is additive manufacturing. Additive manufacturing, again, it's part of the superintelligence, type of thing. And what are we trying to do here, right, with additive manufacturing? Well, sometimes it's called 3D or 4D or 5D, whatever kind of printing you want to call it. But really, this is about, precision manufacturing, right? And precision manufacturing means that we can do very intricate and complex designs at very low cost. Okay. Now, of course, one immediate benefit of this is organ growth, growing organs.
By now, you've probably heard of 3D printing. From car parts and plastic toys to works of art and even desserts, 3D printing offers endless possibilities in our increasingly DIY world. Perhaps one of the most exciting and promising of these is the ability to print human tissue and organs. It might sound like the stuff of the future, but as highlighted in the August issue of MRS Bulletin, the era of 3D bioprinting is here. And if researchers can work together to solve the major challenges facing this rapidly growing field, they could make organ and tissue engineering as easy as pushing a button. By far the greatest challenge in printing living matter is making sure that matter stays alive, both during and after printing. Cells thrive within a narrow range of temperature, pressure, and oxygen level, and must remain sterile. Bioprinting experts must therefore ensure that the inside of their devices and, more importantly, the inks that they print with provide a bio-friendly environment. For material scientists, the issue represents an important design problem, giving liquid-loving cells a happy home while making implants strong enough to keep their shape once in the body. Researchers have devised several creative solutions to that problem. For example, using biocompatible polymers called bioinks that gel when squeezed out of a printing nozzle. But many other issues still remain. For one, it's not entirely clear how all the forces felt by bioinks affect cell survival, or for that matter, how cells themselves affect the mechanical and material properties of bioinks and printed tissue. And then, of course, there's cost. Even when researchers understand these various structure-property relationships, will bioprinting be affordable? Still, a future where organs such as liver, bone and heart can be printed to order may not be far away. The articles gathered in this month's MRS Bulletin take a close look at how researchers are tackling these and other issues as they vie to bring bioprinting into the mainstream. To learn more about the current status and future of 3D bioprinting, register.
Okay, so so this seems fantastical, but it's actually being done, right? The other prospect within healthcare of additive manufacturing or 3D printing obviously has to do with prosthetics, right? So the prosthetics that we used to deal with in the 1980s and 1990s were very clunky, right? They were not very good. So those type of prosthetics were quite inferior, right? They didn't give the range of motion, et cetera, that patients desired or in many cases needed, right? And so this comes back to quality of outcome, right? What type of prosthetic is ideal? Well, the answer is something that completely mimics the missing limb, right? So we're getting closer and closer to that reality, and 3D printing allows us for complete precision so that they can model your own hand or arm or whatever.
My name's Joel Gibbard, and I'm the CEO of Open Bionics, and we're using 3D printing to create prosthetic limbs. At Open Bionics, we're creating the next generation of prosthetic limbs. I like to compare a prosthetic to a shoe because it has a very similar function. It's something that you wear over part of your body. You have to wear it all day long, and it has to be very comfortable. You have to like the way that it looks and be comfortable wearing it both physically and socially. The product that we're developing at the moment, which is the bionic hand, is for transradial amputees. These are people that have an upper limb difference where they still have some of their forearm, but they may be missing anywhere from their hand upwards. So they still have an elbow joint, and this is where the prosthetic socket connects to their arm, but they don't have a hand. We have sensors that we place on the wearer's muscles in their arm, and when they flex their muscles, we detect an electrical signal from the surface of their skin, and that's what makes the hand move. The hand itself has control of each finger independently, and the wearer can give it commands to do different things, so they can move the fingers of the hand with varying power and speed. So they can move it really slowly or quickly and with a lot of power, and they can switch between different gripping modes, so they can do like pinch grips and tripod grips to pick up smaller objects and do fine tasks. We use our Ultimakers to print all of the manufactured parts inside of the hand. We have the actuators, that's a component that we buy. The circuit boards we've designed, and we get those made externally. But then all of the mechanical components, we 3D print using our Ultimaker printers. We use two different materials at the moment. So we have PLA plastic and a TPU called NinjaFlex, which is like a flexible plastic. So we use a combination of those for different parts of the hand that need to be soft or rigid. We use the flexible parts for the joints of the fingers, and it means that we don't have loads of different parts to manufacture either. We can print the finger as an entire unit with all of the joints built in, and then it just works straight off the print bed. It's so awesome seeing the reactions from people wearing it for the first time and trying it out for the first time. Some people have never worn a bionic hand before, and seeing the satisfaction on their face when they get it to move is really, really cool.
Okay. So yeah, so that that's basically additive manufacturing, 3D printing or whatever you want to call it. Let's move on to the next pillar, which is augmented virtual and mixed reality. Continuing on in our super intelligence so-called series here. So I'm not sure if everyone knows, what is augmented reality. Of course, we've seen Android and Apple release their AR kits. Apple, of course, in their latest phones also has LiDAR, right? And so this kind of opens up a whole new world, right, of augmented and mixed reality. And what can, AR, VR, MR systems be used for? Well, first and foremost, they can allow you to essentially become super intelligent, right? What does that mean? Well, any object that you're looking at, whether you're wearing VR or augmented reality goggles, or you're using a tablet or something, any kind of object that has been enhanced, you can just move that goggles or device over, and you'll get information about it, right? So this could be, for example, for preventative maintenance purposes. It could be for repair, right? Or it could just be for informational purposes. What is the temperature of the device and blah, 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 right? So if you can see if it's operating within normal parameters. So this allows you essentially to become, super intelligent, right? And the same can be applied, to the human body, right? You could imagine a doctor looking at a patient, and they're looking at the patient, right, and they're seeing like all of these things all over the patient, brain function and vascular function, cardiovascular function, nerve function, etc. Like kind of like a dissection, of the patient, right, of what's going on inside the patient. So this may sound like science fiction, but it's not, right? So this is what this allows, right? So why don't we take a look at live streaming surgeries and see how AR, VR, MR can be applied. So basically, this is like telepresence, right? You can actually be like within the operating theater, Right. So anyway, I'm not going to spend too much time on this. I think you get the point, right? So we'll move on from here. So as I mentioned earlier, right, one of the advantages, of course, is in learning and training, right, using these technologies, AR, VR, MR. So let's take a look at an example of how anatomy class can be completely transformed, right?
This is really going to help the teachers to get the students to understand how different aspects of the body interact. One of the first things that the teachers mentioned when they were looking at visible body was, hey, this is how I can teach this concept.
They have a hard time with large diagrams on their test for medical terminology. So looking at visible body and having them work with that, they are remembering exactly where those parts go, and that's improving test scores.
We are excited to partner with Visible Body and bring the Human Anatomy Atlas to zSpace. Students can now combine the power of screen-based virtual reality with the rich, detailed anatomy of Visible Body.
It's not like seeing things on a paper because it's 3D. You can churn it and you can look inside of different things.
So I thought that was pretty amazing that the kids can actually take over and do it, and they can teach each other.
Through Visible Body, I just really anticipate some deeper student understandings of the concepts that they're going to then apply in medical career.
Right. Okay, so let's move on, right, to simulation, right? Simulation. And so now we're getting, more into the hyperconnectivity side of things. So the term simulation refers to imitation over time of the functioning of a real process or device. One of the most common applications of simulation in IR4 is digital twins, right? And the idea, obviously, of digital twins is that we can mirror what is happening in the physical world, right, in the computer, right? And so that way, we can actually look at the computer and do what-if scenarios before we try something out, in the physical world, right? So that's one of the biggest benefits. But of course, there are others, right? Identifying manufacturing bottlenecks and opportunities, right? So these are part of the what-if scenarios. Identifying cost-saving opportunities, validating the expected performance of new and existing production facilities or value streams. So these are all potential what-if scenarios. How can we apply this then to healthcare, right? Let's take a look, right? I mean, I think you've pretty much figured this out, right? Because we can do training simulations, right? And they actually have a word for this. They call this S-learning, or simulation-based learning. And this is actually being done today in the United States in a number of hazardous professions. You know, and I saw a video on social work, right, where it's actually applied. So it's kind of like, you know, you're surrounded by actors, right, and you're actually simulating a scenario like a domestic violence scenario, and it was pretty amazing. And you know, this actually prepares people for those type of jobs, right? So let's take a look at this example here.
How would you like me to proceed?
Choose a location for the chest drain insertion site.
Okay. So yeah, so that's, you know, those are examples of how AR, VR, MR can be applied within a, you know, a healthcare setting, right? A digital healthcare setting. Let's move on to the next kind of pillar, which is big data, right? So big data is over here on the super intelligence, you know, spectrum, right? So I think we do have a good understanding now of what is big data, right? Basically, the idea of big data, right, is essentially your digital footprint, right? We want to know digitally what is happening to you and to your body, right, in real time, right? And you know, so that's all possible, of course, through wearable devices. And of course, if you're in a clinical setting or hospital setting, then you'll have, you know, gadgets all plugged into you. And then, you know, that communication can happen, obviously, you know, in real time, right? And so you can build that kind of profile of who you are, your digital kind of profile, healthcare profile in real time. And of course, a doctor could come in with an AR or with a tablet and, you know, essentially just get everything, you know, about you that they need, right? I think that in the future, probably we would have, you know, digital healthcare glasses, right? So that when you look at a person, right, you'd get all their information coming, you know, from all these big data analytics. And that's how, you know, you would do your rounds, right? As a physician, as a clinician, you would just be like walking around, looking at people, you know, in your fancy glasses, and you're getting all this information about them. And also, you know, you would be directed to certain rooms where, you know, there's a concern, right? So this also is interesting because one of the biggest benefits of doing this super intelligence aspect of it, right? One of the biggest benefits of doing this is that you don't have to have that doctor necessarily doing the rounds. I mean, a nurse could be doing it, you know, because the nurse would have access to that information just as the doctor did. And so it's just the ability to deal, you know, with those clinical issues that would require a physician, right? But in most cases, in quite, you know, majority of cases, that would not be the case where, you know, basically the nurse would be able to handle those issues. And so that reduces, you know, cost and reduces, you know, the need for physicians to always be on call. Applications of big data in healthcare. So patient predictions for an improved staffing, this is what I was just talking about, right? Electronic health records, of course, that's what it allows you to. And then, of course, you can visualize the person based on their EMR or EHR. Real-time alerting, yeah. Enhancing patient engagement, right? Essentially, you know, patients that, you know, are suffering, whatever, you know what they're suffering, right? You can actually have a deep understanding of what they're going through, right? Instead of them trying to relay through words, what they're feeling, right? Fraud detection, right? Insurance claims, I think we would know exactly what's happening within that patient, right? So they wouldn't be able to claim, with crocodile tears, oh, my back hurts, right? So we would actually know, if their back hurts or not. Medical imaging, right? Again, we've seen what happened, with AI/ML, with radiology, right? Machines are getting much better diagnosis. Okay, so that is the end of part 2. And let's go on with another quiz. So I'll stop sharing and hand it off to Azhar. And hopefully we can paste that link again, or I can show I can show my screen again if we need to scan the QR code. Do you want me to do that?
Maybe you can share the QR code first.
Yeah, let me do that again then. Okay, so let's go back. Yeah, so please do scan, and we can start the quiz.
So we're giving another 1 minute to let everyone join in.
Sure.
So the end of the part 2 will be the start of the part 2 quiz. All right. We wanted to see how actually our audience is perceiving our webinars and how do they understand our contents. Give it a moment. I forgot to share the sound. All right. Okay, so no one yet is joining. We're waiting.
Okay, we'll wait a bit. I hope that they're able to reach it.
Invalid game code?
Maybe there's an invalid code, or who knows? Yeah. That would explain why there's 0.
Refresh. Oh, man. Stop sharing. Oh, man. It will be quick. New link. So let's say I'm giving another minute.
So it looks like the link was definitely the problem. Yeah.
Yeah.
Okay, great. Well, I'm going to stop. I think I can stop sharing, right? Or do you want me to continue sharing?
Yeah, you can stop sharing.
I can stop, right? Yeah. Okay, great. Okay.
Mario crowds were little fun games. We'll start in a bit. Anyone, please join in if you like to. Even in the middle of the session, if you like to join, you still can join in. There will appear like instruction above my screen. All right, so maybe we can start now, and the others can join in later if you are interested. Thank you. All right, first question. Time's up. So what is all right? Sure. Autonomous system like robot is flawless such that it learns medicine more rapidly than human who has doctorates. Yeah, actually we have autonomous system just to assist us, making it more convenient process, but it's not replacing us as a human. I think this is most of the major thing that people are afraid of, robots replacing human. So let's take the next question. Why does interest in developing functional processes yet already image? Oh, genius. So actually, all of them are true. So the next questions. This is more of a poll rather than a quiz. We are interested to know about your opinion. All right, time's up. So what is your choice? So you are interested to have your limbs or your body to be enhanced if required to. And there's two of you are saying, yeah, definitely, maybe it will be fun. And just one of you are actually not very sure or very cautious about the process. I mean, it is understandable. But most of you are actually open to the idea. How might augmented reality be mainly implemented in healthcare? Time's up. Okay. So augmented reality can like piloted or assisted surgery with virtual recorded guidance. At the moment, this is not yet happening, but this is a possibility. Teleconferencing between doctors and medicinal experts, it is in the industry of healthcare. Yes, it is possible, but in the context of healthcare state, the context of in healthcare, it's not really like the right answers to it. Next question. It's more like a case scenario. Time's up. Awesome. So I guess it's hard. So the best way to deal with this is actually to simulate the scenario. So we've covered a simulation previously. So simulation is actually the best way to go for it. Administering the drug to several children with similar immunodeficiency virus is not actually the best choice because HIV is the evolved one. So you are not going to expect it will reacting to the other virus similar to what it is purpose for. Next questions. I think this is the last one. How big data serves for healthcare? Cole Steven. Yeah, the right answer will be medical imaging. Virtual diagnosis is a possibility, but it's not an ethical possibility because you cannot actually diagnose biological symptoms from just a data. That will be a risky choice. And yeah, luckily no one is choosing for advertisement. I mean, it is also possible, but yet again, it's not always, it is not for healthcare. It's just a good things in healthcare industry. I believe that is all.
Okay, great. So let's continue. And I'll share my screen again. And we'll be able to continue for where we left off. Okay, so the next pillar, let's move on. We're going through this relatively quickly. So Internet of Things is the next pillar. This is part of hyperconnectivity, right? And we're talking about the Internet of medical things now, right? So a report by Allied Market Research predicts that IoT healthcare market will reach 136.8 billion by 2021. Today, there are 3.7 million medical devices in use that are connected to and monitor various parts of the body, right? The Internet of Medical Things refers to the connected system of medical devices and applications that collect data that is then provided to healthcare IT systems through online computer networks. So I think a lot of you are already familiar with Internet of Things. If we're talking about, smart wearable devices, if we're talking about sensors, we can even talk about smart, rubbish bins, smart lights, right? The kind of things that we would see in smart cities. A lot of that is going to be driven, right, by Internet of Things. Of course, home appliances, home automation, right? That is something that we commonly see, right? Let's take a look at in-home patient monitoring, right? When we were talking about quality of outcome, we don't want, elderly people or people with conditions requiring hospice care. We don't want them to be in a clinical setting, right?
In 43 of the past 50 years, healthcare spending has outgrown GDP. The US spends about $3 trillion a year on healthcare, which amounts to about $10,000 per person. Healthcare has been relegated to a series of innovations that have been about preserving the status quo and helping existing participants advance their business. Where the Internet of Things becomes interesting is it has the potential to totally change the way US healthcare works. So as we think about how the Internet of Things might develop, there clearly is a large commercial opportunity. This could be something like a $30 billion industry, up from nothing today. When we think about the Internet of Things in healthcare, we're thinking about mobile devices that connect all the different participants, the patient, the caregiver, a provider, and allows for information to be delivered that informs a clinical decision. So when we look at the Internet of Things, we identified 3 key categories. The first is remote monitoring. And think about remote monitoring as a way to constantly connect a patient and a caregiver. So a patient goes and has a procedure or has a specific condition, and remote monitoring allows that patient to be evaluated all the time from anywhere around the world through a smartphone or a tablet or some type of implant. And one example I think that tells the story about remote monitoring is diabetes. So diabetics have the need to monitor their glucose levels all the time. And what remote monitoring does, it connects glucose readings to a smartphone, to a physician, and that closed ecosystem allows a doctor to modulate someone's care. The second area is telemedicine. And telemedicine is among sort of the quote lowest hanging fruits here. And the reason for that is it's essentially just adding on another activity to one of the many, many things that people now do on their smartphones versus what might have been done in person even 5 to 10 years ago. And as you think about adding applications to a smartphone, where telemedicine becomes so interesting for the Internet of Things is you can reduce a lot of headache in terms of basic medical care. If you have a child who has an ear infection, you can do all that remotely. So think about all the time you save. You're not going to a doctor. You're not making an appointment. You're not traveling. You probably don't even have to go to a pharmacy to fill a prescription anymore when you link that all together. The third area is behavior modification. And essentially what behavior modification involves is identifying certain health characteristics and communicating with patients about what they should do to address those health characteristics. So great example will be high cholesterol. So what behavioral modification technologies offer is almost like an instruction manual. And the ones that we think have the potential to be most successful are sort of like a life coach in your pocket. Like any new technology, the Internet of Things for healthcare is going to face a series of challenges. The US healthcare system has so many participants, payers, doctors, hospitals, patients. All of those individuals need to be on the same page to make this technology work. Taking a step back, this technology has the potential to take a system that's been really slow to change and turn it on its head, where by the next 50 years look completely different than the prior 50.
Okay. Right, now let's take a look at a pill cam, right? This one has no sound from what I can tell, so yeah. If anybody has seen the movie Inner Space, it's a 1980s movie, Hollywood movie. It's like that. Okay. I'm assuming that's a polyp or something. Right. So basically, what we can do, with these type of devices, is essentially map out, parts of the human body, right, and identify the regions that are of interest, and then physicians obviously can look at that data, or even machine learning algorithms, and determine, cancers and all these other conditions, and then of course we can treat it. Okay, let's move on to the next pillar, cloud computing. And so here we have cloud computing. So cloud computing, of course, is very advertised topic nowadays. Cloud computing is all about computing at scale, right? It's about decentralizing your data center and virtualizing it, and then of course operating it at scale. Okay. How does cloud computing apply in healthcare? Well, as the video mentioned, a couple of videos down already mentioned, we're talking about a lot of players, right, in a healthcare system, right? We're talking about doctors, family members, different types of regulatory authorities. We have physical activity service providers. We have the patients themselves, right? And we have all the devices in between, right? And of course, the pharmacist, yeah. So how do all of these work together for a holistic, high quality outcome, right? That's the goal here, right? So why should, health workers switch to the cloud, right? Well, of course, for one thing is that they benefit from economies of scale, so cost is, reduced. The other benefit, of course, is that it's completely decentralized and virtualized. What does that mean? Well, it's greater reliability, right? And reliability is crucial when it comes to healthcare, right? Let's move on to cybersecurity. Cybersecurity is over here. Let's take a look at what we're talking about here when we talk about cybersecurity.
Cybercrime is a global problem that's been dominating the news cycle. It poses a threat to individual security and an even bigger threat to large international companies, banks, and governments. Today's organized cybercrimes far outshadow lone hackers of the past. Now, large organized crime rings function like startups and often employ highly trained developers who are constantly innovating online attacks. Most companies have preventative security software to stop these types of attacks. But no matter how secure we are, cybercrime is going to happen. Meet Mia. She's the chief security officer for a company that makes a mobile app to help customers track and manage their finances. So security is a top priority. Mia's company has an incident response platform in place that automates the entire cybersecurity process. The IRP software integrates all the security and IT software needed to keep a large company like Mia's secure into a single dashboard and acts as a hub for the people, processes, and technology needed to respond to and contain cyber attacks. Let's see how this platform works in the case of a security breach. While Mia is on vacation, irregular activity occurs on her account. A user behavior analytics engine that monitors account activity recognizes the suspicious behavior involving late-night logins and an unusual amount of data being downloaded. This piece of software is the first signal that something is wrong. An alert is sent to the next piece of software in the chain, the Security Information and Event Management System. Now the IRP can orchestrate a chain of events that ultimately prevents the company from encountering a serious security disaster. The IRP connects to a user directory software that Mia's company uses, which immediately recognizes that the user account belongs to an executive who's on vacation. Next, the IRP sends the incident's IP address to a threat intelligence software, which identifies the address as a suspected malware server. As each piece of security software runs, the findings are recorded in the IRP's incident, which is already busy creating a set of instructions, called a playbook, for a security analyst to follow. The analyst then locks Mia's account and changes her passwords. By this time, the software has determined the attempted attack came from a well-known cybercrime organization using stolen credentials. Mia's credentials were stolen when the hackers found a vulnerability in her company's firewall software and used it to upload a malware-infected file. Now that we know how the attack happened, the analyst uses the IRP to identify the specific server vulnerability that allowed the attack, what other machines on the network are vulnerable, and the malware file. The IRP uses information from the endpoint tool to determine which machines need to be patched, recommends how to patch them, and then allows the analyst to push the patches to all the computers and mobile devices instantly. Meanwhile, Mia has to alert the legal department of the breach. The IRP instantly notifies the correct person of the situation and the status of the incident. After the attack is contained and Mia's account is secure, the analyst communicates which data may have been stolen or compromised during the incident. He identifies which geographies, jurisdictions, and regulatory agencies cover the users and information affected by the attack. Then the IRP creates a series of tasks so the organization can notify the affected parties and follow all relevant compliance and liability procedures. In the past, a security breach this large would have required Mia's company to involve several agencies and third parties to solve the problem, a process that could have taken months or longer. In a matter of hours, the incident response platform organized all of the people, processes, and technology to identify and contain the problem, find the source of the attack, fix the vulnerability, and notify all affected parties. And in the future, Mia and her team will be able to turn to cognitive security tools. These tools will read and learn from tens of thousands of trusted publications, blogs, and other sources of information. This knowledge will uncover new insights and patterns, anticipate, isolate, and minimize attacks as they happen, and immediately recommend actions for security professionals to take, keeping data safe and companies like Mia's out of the headlines.
Okay, so I think we've seen a lot of buzzwords here, right, being used, right? Incident response platforms and SIEM. Maybe you've heard of IPS IDS firewalls, right? CVEs and all this other stuff. So this is all part of, cybersecurity, right? And how does that apply, in healthcare, right? But before we kind of get into that, what are the goals of cybersecurity? So number one, of course, is protect the confidentiality of data, preserve the integrity of data, and promote the availability of data for authorized users, right? There's always a balance, right, between convenience and security, right? And we have to maintain that balance properly. So this is just a typical cybersecurity framework. We are not going to get into this because we don't have time to do that. But this is just there for your reference. These are the types of cyber attacks. And again, I'm not going to go through this too much, but this is there for your reference. In the attack, for example, that we saw where the credentials were stolen, we see the use of stolen credentials, right, in the video. So the types of cyber attacks can be broken down into two major categories: web-based attacks and system-based attacks. Okay, web-based attacks obviously are plentiful, right? Because we all use the web, right? That's the number one attack vector, so to speak. And of course, you can fool people very easily, right? There's a number of techniques that are available. Systems-based attacks are a lot more difficult, depending on how secure your network is, right? So depending on the security of your own network, systems-based attacks can or cannot work. A lot of people will use social engineering to compromise systems. Like for example, pretending to be someone who's authorized, right, in order to gain access. Okay, threats to e-commerce. We've already known about this. So in terms of healthcare, because we didn't really go into any kind of example within healthcare, there have been numerous examples of cyber breaches in healthcare, especially ransomware, WannaCry. A lot of hospitals and clinics were affected by ransomware. And of course, all their data, that critical data, was encrypted, and they had to pay Bitcoin in order to decrypt it, right? So this is a huge concern because if we're talking about personal PCs within hospital clinical settings, a lot of them are obviously not secured, latched down, or patched, right? So that remains a central concern within a medical setting. Okay, let's move on because we're running out of time here to systems integration. Systems integration is over here. And I believe that would be the last one. So I think we'd be pretty good in terms of being able to finish on time. So with Industry 4.0, companies, departments, functions, and capabilities will become much more cohesive as cross-company universal data integration networks evolve and enable truly automated value chains, right? So that's a bunch of fancy talk, right? Right? What it actually means is hyperconnectivity, right? So we're trying to connect everything together from very diverse, environments. So connecting IoMT, right, Internet of Medical Things, with the big data analytics, right, with the AR, VR, MR, and with simulation-based learning. If you just connect that all together, right, essentially what you get, right, is a formula for high-quality healthcare, right, where costs are reduced, you get more precision, essentially the outcomes become much better, right? And so systems integration is all about how do you connect all these things together, right? Now the cloud is one integration pattern, right, where we can essentially move things to the cloud and use cloud services for integration, right? Because anyway, they're already integrated, right, in the cloud provider. So that's one strategy you could use, right? This is just a diagram of a typical kind of integration, right? With your electronic health records, right? With the pharmacy, with the lab, getting back your test results, right? And of course, with how much money you have to pay, right? The administrative financial part of it. So you would obviously want all that stuff to be integrated. Let's take a look at this video and see how that would look like.
This is Maria and her partner, Ruben. Before their day even starts, they are providing a detailed snapshot of their health and wellness to their network. Maria slept great, but Ruben, who has a history of depression and anxiety, tossed and turned all night. Data from his neuroendocrine system shows a spike in cortisol. That may be a sign that he could be headed for a significant depressive episode. So, before he's even awake, his network has placed time in his busy schedule that day to talk with a virtual therapist about ways to reduce his stress. 20 years from now, radically interoperable data and open and secure platforms will allow consumers to own their own journey of health, providing them with a holistic, real-time view of themselves and their environment. A system in which personalized experiences that are highly tailored to one's preferences and needs are the norm, not the exception, and where care and services can be accessed quickly and seamlessly. Consumers are increasingly willing to share their personal data through wearable technology, smart appliances in the home, and even with the home itself. This vast pool of data forms the basis of their personal health profiles, so that changes or deviations can be detected and addressed immediately. This information empowers consumers to take control of their well-being in ways that were impossible in the past, whether it's proactively heading off depressive episodes for Ruben, or getting Maria her time-released antihistamine well ahead of a high pollen day. This data also provides more opportunities than ever to glean novel insights into the health of entire communities, and to enable research and scientific breakthroughs at a rate that will only increase exponentially as technology continues to evolve and to integrate into our daily lives. Tailoring care individually based on ever-advancing capabilities to capture, interpret, and act on near-perfect data in real time is a radical change. This change will require a complete rebuild of today's healthcare system and the collaboration of several actors, some old and many new. Those with deep roots in care delivery must ask themselves how they can use data and technology to transform what well-being and care delivery means. Players in the health ecosystem will include non-traditional ones. For example, those focused on the data platforms and tools that enable this new model of health. And regulators, financiers, and intermediaries will all play a new role in this new vision. Disruptive thinking and a commitment to emerging technology are more important than ever before, because the future isn't as far off as it seems. In fact, it's at your very fingertips.
Okay, so yeah, we're finally at the last quiz, and I'll stop sharing. I hope. Well, I'll stop sharing in a minute, right? Because I want people to be able to scan. Oh, we're skipping the quiz. Okay, I think we're running out of time, right? So let me just continue. I think we're pretty much done. So we're going to finish off with AI in healthcare, and then we'll be done. So in terms of artificial intelligence being applied within healthcare, right? Let's just watch some examples of algorithms being used.
Making a difference. Radiology. In 2018, a deep learning-based algorithm was developed using more than 50,000 normal chest images and almost 7,000 scans with active TB. The algorithm became so good that in performance tests, it easily beat radiologists. Of course, it has its shortcomings, but this test shows that even the AI of today can be a helpful second reader for physicians, while the AI of tomorrow can bring screenings and precise diagnostics to even the less developed areas where medical professionals are not available. Dermatology. AI is advancing elsewhere too. Researchers in Germany, the US, and France trained a deep learning neural network to identify skin cancer by feeding it with more than 100,000 images of malignant melanomas and benign moles. After this training, they compared its performance with 58 international dermatologists, and the results were remarkable. While the dermatologists accurately detected more than 86% of the melanomas, the neural network detected 95% of them. Oncology. One of the biggest promises of AI is that one day it could crack the code of individualized cancer diagnosis and treatment. And Watson, IBM's very own AI, is a powerful tool that is mainly being used and tested in the field of oncology. So far, dozens of hospitals have adopted this technology, and it's being used in conjunction with medical judgment. While its promise is strong, it has not yet been able to live up to the expectations in the fight against cancer. Cardiology. Cardiovascular diseases are the #1 cause of death globally. For those affected, early detection is critical for both management and treatment. And in the future, AI-based predictions could be a lifesaver. Since studies have shown that markers of cardiovascular disease can often manifest in the eye, scientists are using deep learning methods to identify risk factors such as age, gender, smoking status, and blood pressure, only by looking at the eye. These new studies still need to be validated and repeated on more people before they become more mainstream and gain broader acceptance. But since retinal images can be obtained quickly, cheaply, and non-invasively, that will probably open new horizons in healthcare. Well, AI has several limitations. Most of these studies have not been tested under clinical circumstances, and algorithms are only precise in a specific task, while clinical life is much more diverse than that. Nevertheless, what matters here is that AI has amazing promise, making a difference.
Okay. Let's look at the benefits and risks, and hopefully we can...
A third of U.S. physicians are already using artificial intelligence, or AI, in their practices. And many believe there is ample reason to think this advanced technology can help address diagnostic errors, the largest cause of malpractice claims. A recent physician survey by the Doctors Company, the nation's largest physician-owned medical malpractice insurer, found that 53% of physicians are optimistic about the prospects of AI in medicine. 35% are using AI in their practices. 66% believe that AI will lead to faster diagnoses. 66% believe that AI will lead to more accurate diagnoses. Potential benefits from AI in healthcare include assistance with case triage, enhanced image scanning and segmentation, supported decision-making, integration and improvement of workflow, disease risk prediction, patient appointment and treatment tracking. But there are also potential risks, such as false positives or negatives, systems error, over-reliance, unexplainable results, unclear lines of accountability, new skill requirements, network systems vulnerable to malicious attack. To lessen these risks, physicians must seek training in the use of AI and adhere to the standards provided by the device companies. Training will also enable physicians to fully and clearly articulate potential harms to patients in order to obtain true informed consent. The AMA also has proposed that AI training should be incorporated as a standard component of medical education. Hospitals and other practices are also key to ensuring proper development, implementation, and monitoring of protocols and best practices for use of AI systems in healthcare.
Okay, so we're going to end with health chatbots, right? So health chatbots obviously allow you to interact in a very natural way about your health, right? So this essentially enhances the customer health journey, right? So it'll be able to share information with you through a natural interface. And yeah, that's it. Let's move on to the question and answer portion, as well as the rest of the presentation. Thank you so much.
Thank you, Dr. Tarun. Thank you so much. There are some FAQ and Q&A questions in the comments. Because of time constraint, I don't think we'll be able to go through every one of them. In the meanwhile, let me share my screen, and I would like to offer, some interesting feature of our platform to the audiences right now. Then, if we have more time, we'll be going through the question and answer later. So I hope everyone enjoyed Dr. Tarun's session. If you have any question, right now we see a lot of questions in the chat box, in the comment section. Don't worry, we are going to reply to you ASAP, and you'll be able to connect to Dr. Tarun later on in his LinkedIn for any further questions. We from CATS as well will be able to help you with any further inquiries for you to get more resources to learn about data literacy skills, give you resources, and find you relevant jobs in the future in case you want to explore the career of data science. So let me introduce to you Rubik. Rubik is a platform created by CATS to provide talents with data literacy skills, resources, and relevant jobs. So in the platform, you will be able to perform skill verification. We have identified altogether 32 skills that you can explore to improve your skill in the age of AI. Those 32 skills includes, data storytelling, data visualization, maybe some kind of machine learning and other techniques, for you to improve your skill in terms of data cleaning and how to work with data in an integrated format. So you will get certified by us as well and get matched to jobs that are available for you in the future. So in the system, in the platform, you'll be able to also look at, get different skills, for example, Python. And whenever you get a higher ranking, you get a better match to the employers to get, jobs and projects. So in the platform as well, we will be able to offer you different learning path, which is personalized to you in case, for example, you are from a healthcare industry, but you would like to learn some additional skills to work with big data sets from healthcare. We have so many different data points for healthcare industry. So this is one of the way for you to understand and identify which skills do you need and which course do you need to take, or what other learnings you should equip yourself with in the field of data science, business analytics, and AI for you to advance your career. So different companies are here in our platform to offer you jobs as well. we are going to do job matching to companies like Astro, Axiata, Cellcom, UEM, and more companies will be coming into our platform to offer you data and AI related jobs. So if you are in the any field, it's not only limited to anyone who knows computer science or technology. As long as you have certain background in the science and technology arena, you should actually join Rubik to learn, to upskill yourself, to network with different data professionals, get mentorship, and perhaps in the future join the hackathon and competition that we are going to launch in the future to improve your skills and make sure that your career is future-proof with additional advantages in the age of AI. So these are some benefits when you join Rubik. Rubik is a platform for a data professional community. This is a place for you to do networking, to build your personal brand by creating a profile on the platform. People know you as a data professional who knows a certain kind of skill related to data and AI. You can build reputation here over time as we grow the community. You gain verification and trust by scoring certain skills in the system as well. So for students from APU, we will also like to invite you to join Data Star Graduate Program. This is a fully sponsored program for you to learn data science and become a data professional in the next 1 to 3 months, depending on which track you are in. Yeah. So after the graduation, after you have completed the program, you will be placed to work in a company, in the company that are our hiring partners for 12 months. For 12 months, so that you'll be able to get real work experience as either a junior data scientist or data analyst or data engineer. So we are expecting more than 500 data stars to be trained in the next 2 to 3 years. And we are also getting more grants and scholarships for you to join the session. So these are some of our success stories. Our graduates actually managed to get jobs in, Cellcom, Huawei, Maybank, CIMB, Ernst & Young, and many more. So these are some of our hiring partners. If you are graduating soon, or if you have graduated and have not found a job, do go to our website, thecats.com/datastar, to join in, to participate in the session. So right now, because all of you are here and we would like to reward you with free access to Rubik platform, go into the platform and register yourself. You'll be getting a complimentary Big Data Analytics 101 course where you get a certificate of completion within 3 to 7 hours after you have completed the course. So the course only takes half a day to finish. If you finish it, just sit down and learn within the 3 to 7 hours. By the end of the day, you get a certificate which will enhance your resume. It will be live on LinkedIn as well. So do take advantage of this, and we wish you to quickly go and sign up for Rubik so that you get to learn Big Data Analytics 101 before you enter the workforce. And also in the system, there are skills assessment that you can take so that you'll be able to find out which skills are in demand, which one do you have, which one do you not have, and which one do you think you want to pursue to learn further, so that in the future you can become maybe data analyst, better data presenter when you work with a lot of data in the future. Also, you'll be able to, maybe you want to change your career to become a data scientist instead. So these are we have resources and skill assessment for you to do and get certified as well. Get certified in the sense that you get to add additional certification, which is industry recognized, to boost your resume for better employability. So that's all for Rubik for now. If you have any question, do reach out to us. Our website is www.thecats.com, or you can send me email at engage@thecats.com. Okay, back to you, Dr. Guma.
Yeah, thank you for enlightening presentation on AI with healthcare, Dr. Varun. Along with you, your crew members make the session as a very interactive and interesting way. So as most of our audience with us from, data science background right now, they would have started to correlate AI with healthcare. We all know medical field started to adopt AI system to deal with data. All right. So let me once again thank you, Mr. Tarun and team for sparing your valuable time in spite of your tight schedule. Thank you, my dear participants. Without you, all this webinar wouldn't be successful. So thank you once again for joining with us. Have a good day. Take care and stay safe.